Alright, this is a simple tutorial on just physical computer, right? Know how to assemble it, identifying parts. Only thing you really need, screwdriver, a thermal paste. I have extra here just in case. Alright. There are many different computers. Some of them open differently. This one, just like most businesses, are actually pretty good. Like the Dell computers. All you gotta do is just see this one, press down on it, then grab this other one, and you slide it out. Easy enough. And there, you're already inside, right? You don't have to screwdriver it open like some other ones. Yeah. So we can start with the hard drive, right? Yeah, some of these still use hard drives, because they're very cheap when it comes to space. So open this up, right? Only thing you gotta do, see the lock, switch it to unlock, and then you just, you should be able to just, right. It has arrows, right? This is what, like, my double ones have blue and the arrows, to let you know like what to do. Right, after you do that, it's open. Great. Behind here, I'm pretty sure it's actually a CD drive, right? Yep, CD. In terms of, I don't think I actually need to do anything with this. I don't plan on changing this because this is the computers, the schools. So I'm just gonna keep this inside. But if you wanted to, you could easily, right, just disconnect these. So you can see at the bottom, they match up. They're not double angled. You can't just do like this and then like this. There's a thing on the bottom that prevents you from doing that. If you wanted to change out the hard drive itself, actually, this is how a screwdriver screws. Well, these are more complicated. Yeah, you gotta. Some of these new ones, you have to remove this first to be able to remove the hard drive itself. But like I said, I don't plan on doing that, so I'm just gonna keep it as it is. That. That. Like that. Yep. What I gotta do is put it back. It's gonna be a little bit weird. Will not lie to you. It's gonna be a little weird. So there should be a thing at the bottom. Yep. Yeah, these are weird. But eventually, right, like it's there. Push it in. There you go. Now you can lock it. Easy as that. Yeah, this has some things that stick out. A little bit weird, but they're good. This specific one does have a thing, right, just for the cables to be able to slide through, slide out. Yeah, you can see it there. Easy. Alright. In terms of next, you can also get rid of the CPU. CPU is not that hard to deal with, right? You have a bunch of screws. The thing on top is actually the cooler. This is really important. These, unlike our Chromebooks, they have fans because they're actually kind of decently powered, so they generate a lot of heat, so you need to dissipate it. So to remove it, all you gotta do is just find the right direction to twist this. Actually, is that removable? I think I gotta remove this one first. Or you gotta move this out the way and then you can. Yep. And then you just start removing. Or not. Actually. Oh, I don't think that's connected to. That's connected to something else. You gotta remove this one first. Okay. Yep. This one, let's go, no problem. I think those are probably the anchor. But right? It's been removed. Try not to lose your screws. I don't have a screw tray, so that would be ideal. So I just have to, you know, put it and hope they don't roll away. Next, you just remove this screw. There's a hidden screw behind here. These are a little bit crowded. Yeah. Honestly, these I should removing these, which would probably make it easier. But I'm gonna just keep it there. Do is screw that. We can get rid of that after, right? So, oh, and there's a final screw up right there. They're at the bottom. See it? These are the screws connected to the black parts, not the silver ones. Right, now you just pretty sure there's a manual somewhere. I might have to read it eventually. But it's good, right? So you got rid of. Oh, this is a 2-part cooler. Oh, that's weird. Okay, so this is actually cool. I don't see a lot of coolers like this. Most of the coolers on the market, earth coolers at least, are just 1 part. But this is actually fascinating. So, oh, you can just remove this too. So, what does it say? Alright, there we go. Alright. So this is the fan, right? You see it? Just spins. Right. This is what blows the air. As this part, right, just directs the air to go outside the case because here is, well, yeah, that's where you ventilate. The silver part itself is actually the heatsink. This is really important because if you just put a fan on top of the CPU, you're just kind of just blowing air into it. But it's not really that effective because you're not really pulling air away from the CPU. You're just pushing at it, which doesn't mean it'll get on the motherboard. And it doesn't cool that well. The heatsink allows for the CPU to, well, push the heat into the sink, right? In the name sink. So then the fans can blow on the heatsink. And since it's a larger surface area, it'll do it more quickly. It's dissipating, can direct it out, won't get the whole computer hot. It's better. It means the computer can run at a higher TPM or higher wattage for more power. I'm sure you can find videos online where it's like the computers before the heat sinks or whatever, and they just get on fire. Easy. Okay, before I continue, hard drive. Tell me its uses. Well, storage, yeah. Alright. So now to get rid of these, right, this is what connects the heatsink itself. So you need to remove this in order to access the CPU itself. Like I said, this is actually cool. Most CPUs on the market don't even do this. They don't even have a 2-part. They're just 1 part now. Just fine. It's just interesting. In terms of removing this, I'm actually kind of confused. Oh, no, never mind. It's getting out. It's just... Yeah, this is really screwed. Holy... Who screwed these in? Hold on, let me open up the rest. I think that's just it shows you. I think if I open all of them up, it'll just lift. That's good. That's good. Yeah, some of these coolers work differently, but they have the same idea. There's also a water version, right? So instead of air, you can get water cooling, like a car. They're usually reserved for like really, really high-powered CPUs. There's some CPUs that pull crazy, like 400 watts an hour. So they get really hot, really fast. They have huge heat sinks, water pumps, AIOs, or custom. They're also very silent because if you try to get a humongous fan, it'll get really, really loud. It's like an AC. But if you have water cooling, it's a lot quieter. Right, so now I should be able to, after that, I should be able to lift this up. You know, screws a little more. Yep. Like I thought, you just gotta unscrew them, like all together. Get that part lifted up. That part lifted up. Yep, that's just this one. Or, yep, it's good. There you go. See that? See that in the center? Don't quite see it. Alright, lift it up. Or, you can disconnect the fan. Fans aren't that hard to disconnect. Or shouldn't. Come on. Does this one have tape on it? Why is it so stubborn? Alright, there you go. Let me get that screw out. Alright, we found it. See that on the CPU itself? It's covered in a paste. This is what we call the thermal paste. Thermal paste. There's very different kinds, very different brands. I'm going to clean this off and apply a new one because if you take it off... Okay, first of all, I got to explain what it does before I can explain to you why I have to reapply it. Basically, CPUs, they look flat. This, if you remove the paste, also looks flat. The problem, however, is the fact that even though machines are very precise, they are not precise to the nanometer, right? If you search up videos of CPUs measured under like nanometer, like microscopes, you can start seeing like, even computer programs can start seeing like, oh, it's not actually flat. There's like spikes and valleys and hills that don't make it perfectly flat. Even though to our eyes and our feeling it's flat, there are spikes because it's not perfect. Nothing is perfect. So because of this, these small gaps, air gaps, they basically make it harder for the CPU to be able to push the air into the heatsink. This is not good because it means it cannot dissipate the heat as well, so it can also overheat without it. I'm sure you can find videos where it's like, without the heatsink, or like once you put in good thermal paste, the temperatures could just drop like 20 degrees Celsius, which allows for way more power. Could be the difference between your computer being nice and cool, and your computer burning up on fire. Yeah. So allows them to be higher power, basically. So the thermal paste itself, because it's a paste, it's liquidy, it's not quite, most of them are not runny, but they're thick enough to where as you push it, it'll fill in all the gaps. It's like Play-Doh. If you push Play-Doh into your hands, it'll basically like, you'll feel it. This is the same way. Pushes it together, so there's no air gaps, and so the air can dissipate more easily, the heat. Thermal paste, right in the name, thermal, temperature, paste. We call it paste. Technically it's called compound, but we call it paste. It is way better at conducting heat than air. I mean, I'm sure you could see this where like, I mean, if you're cooking something in a kitchen, the house will get hot, but eventually. Most of the heat will stay in the oven, or in the heat, yeah. But if you feel like a metal, all of a sudden the heat travels to the metal really fast. Same thing with thermal paste. It allows the heat to transfer faster into the heat sink, allowing for better dissipation of air. It's good. Alright. Not sponsored by Arctic, not sponsored by anything. Just use these because I like them. So to clean it, some of them, like Arctic, are nice enough to provide you a cleaner with a mix. But if you were to not to have that, you could probably find an alternative, like Scott's Shop Original Multi-Purpose. You know, they're blue shop paper for cars. It works just as well. Some of them provide it to you like this. So what you gotta do, right? Just remove this. Easy. Just gotta wipe it. This is old, actually. This might be old. It might not be well applied. So by me reapplying it, it might actually improve the computer's performance. Not that these are like super crazy computers, but yeah. If you were to buy a computer from like a friend or a shop, pre-built, they may use cheaper thermal paste, or may not apply it as well. So if you apply it yourself, it might actually improve the performance by quite a bit. Especially on laptops. If you use a laptop, that's yeah. I used to use one. But alright, now just wipe it off. it off. I think this one's full. Open the second one. The reason you want to use these, and you don't want to use normal paper towels, is because normal paper towels actually have they have a lot of fibers, and those fibers can actually basically stay on the computer. It can cause issues with thermal because again, paper towels are not as efficient at conducting heat than well, I mean they can light on fire, but they're not conducting heat. Not great at just letting the heat travel as compared to like thermal paste. So it's like air. You don't want to have any fibers in there. So I didn't do the best job. There's thermal paste everywhere. Well, not everywhere, but there's some on the edges. Honestly, not a huge issue. Thermal paste is not conductive. It's not super. It's not electrically conductive. So if thermal paste actually gets on the CPU, it gets a little bit around the edges on the motherboard, it won't hurt it. Just don't overdo it. It won't hurt it. Unlike another type called liquid cool, like a metal liquid. I don't really know too much about those, but those are conductive. This can mess up your computer if you apply too much. But yeah, to get rid of the CPU. Oh yeah, the CPU. CPU. Yeah, it's the brains of the computer. It's what It's basically any instruction that has zeros and ones, mathematics. The CPU does it. And a bunch of threads. It does large jobs. It's very important. You kind of need one. If you don't have one, the computer might not turn on. I don't know. But these are lidded down. Usually get rid of the lid. It's not that hard. So I think on this type, yeah, you just push it down. But delidding the cover. Right, we're not deleting the CPU itself. So yep, pull this up. There you go. You got the CPU. I'm actually interested in what kind this is. Oh, this is LGA. So these kinds, basically, you see right here, there are no pins right here. These are all flat. But on the motherboard itself are the pins. It's actually interesting, right? So if I were to pull this up, those are the pins. Be careful with the pins. Do not bend them. So because this is an Intel CPU, these aren't as bad. There's no pins there. But still, you want to be careful with the middle part. If you, damage those, the computer might not turn on. Again. But basically, the pins, they basically connected the CPU to the motherboard. Yeah. Let's see if I can clean this a little bit more. Alright, that's cleaned. It's basically cleaned at this point. Yeah, thermal paste also smells a little different. It also has a smell. It's not a bad smell, but it smells. You'll know when you do one yourself. You'll smell it. Actually, it's kind of dirty. Actually, what in the world? Okay, there you go. Let's see what kind of CPU it is. I'm actually kind of interested. I think you guys in the video can see it. Yep, it says Intel Core i5 8400 with a 2.8 gigahertz and all those specs. That is interesting. Okay, this is a little bit older. 8400s are a very old model. Most of an LGA. I don't know what exactly is the model. No, it doesn't really matter that much. So, I'm not gonna even touch that. That's kind of, you know what? Yeah, I'm not gonna even play with that. If you touch those, you can bend the pins, and it's game over for your computer. Most of these have, yep, you see that? You see the arrow in the CPU? That basically tells you where to put it. So on this specific motherboard model, there is an arrow. Let me see if I can show it in the video. Okay, well, whatever. There's an arrow right there. It's white. Different motherboards have different indicators for, and it turns colors, but whatever. Basically, different motherboards, they'll show you an arrow that basically tells you where to put the CPU. So if you're worried about, oh, what if I place it the wrong way? Just pay attention to the arrows. They'll tell you where to put it. Most motherboards have that nowadays. I don't know, maybe motherboards who don't. Let me clean this CPU up. Alright. Now to put it in. You want to gently just, right where the arrow is, just put it in. Yep. Let me clean that up. You know what? That's not getting cleaned up. That's... Whoa. Yeah, that is not... Yeah, that thermal paste is very, very solid. That is... Wow. It's old. It'll run. It's fine. Like I said, this kind of thermal paste won't ruin your computer if it gets a little messy. You'll be good. Alright, so now you gotta do, right, is put it back. You put the latch back on. Get this part, right. Basically, the latch just keeps the CPU connected with the pins, otherwise it's a little bit loose. Also helps to get the, you know, the heat sink in and the fan. Or water cooling if you're using that, of course. Centered, right. As long as it's centered enough, you really don't have to worry about it being perfect. It'll center it for you. You push it down, you see that latch, connects it, now it's pushed back down. It's good. Wow, that is, yeah. You know what, that thermal paste is bothering my brain. I can't get it out. It won't mess it up. It won't mess it up. Oh my god, yeah, I gotta remove this. Yeah, this stuff has to be removed. So, yep, had to remove it anyways. Alright. This is to be able to access the RAM that's under there. Right, it is covered by the hard drive, conveniently enough. So, to get rid of this, I just gotta get rid of this part itself. Pretty sure if I open these up, it should allow me to just... Oh, yeah, that's what that is. Yeah, because you can remove the thing itself. This is like the AIO. Right, see that? See USBs, headphone jack. Right, you got the power button. Optiplex 3060. If you want to switch it up, great. Oh yeah, these motherboards. There should be a number somewhere. Oh yeah, you see it. Yeah, I can see it. Let's see if it'll focus on the camera. It's right next to the Dell logo. It's like right here. BNO628. That's the motherboard type. You can search it up to see the specs. I think that's focused enough. Yeah, that's long enough. But you can search it up to see the exact specs of this motherboard. What it has, everything that comes with it. Just with that thing, I'm pretty sure that's onboard graphics. I'm not actually sure. It might be the memory controller too. You know, first of all, let me get rid of this. Otherwise, it's gonna be flopping around, and you don't want that. Okay, on this specific kind. Right. Yeah, it's right there. Then you can just. These are stubborn. Wow. Okay. Let's get rid of these. Get rid of this. Hit to the side. Now you just. So I know it's these. All right. Yeah, these are wow. To push these down. You gotta push these down. No, they don't push down. What if I? Alright, there we go. You just gotta wiggle it until it's perfectly fits in or something. I got this the other side, but wiggle it around. Adjust. Sometimes it can be a little bit stubborn. That's just computers. Alright. Got that out. Let me make sure, right? This is for the P3. This one's serial SATA, basically. SATA are the standard for modern hard drives and SATA-based SSDs. They're newest standard. They're the quickest, most storage. Great. Um, CD drives are really not that common to come across. Dells and some business oriented computers still have CDs because well, businesses still use them. But for the most part, most computers will not come with a CD player or writer. You don't have to get one yourself. So yeah, that's actually interesting. See that right there, made in China and everything. 2019. All right, 2019. So the computer was probably made somewhere like 2019, 2020. All right. After you get rid of that, now you got the naked motherboard, basically. All right. I have searched up the specs a little bit. I believe this runs on DDR4. It's not the newest standard anymore. The newest standard nowadays is DDR5. Price is coming down quickly. It is the best RAM currently. It runs quicker. Has a new technology to where... So this only has one RAM stick, right? So if the computer wants to run processes into the RAM... First of all, let's explain what RAM is. So basically RAM, it's like... So you have the storage, right? The hard drive or the SSDs. Those are big, long term, right? They will not corrupt very quickly. And yeah, they store. The RAM is like the quicker. It's like the short-term memory. It doesn't store as much as the storage, as these big storage systems, like the SSDs and hard drives. It also is more volatile, which means there's more chance for like corruption and stuff. But these are extremely quick. These will run through data way faster than an SSD can. So having a lot of it can be really good for people who like edit videos. Because here there's only one stick on DDR4 and older generations. By having two sticks, you basically have like, it's like hyper-threading. Now you can have two processes running, right? If something has to run and another process wants to go, it can also run through the other one, which is way quicker, right? It basically doubles the speed. On DDR5, this has the technology to where there's like a big M opening and like a small opening. You can probably search up a video that goes way more in depth. But basically, simplicity is, because of it, you can basically run like dual channel on a single stick. Having two is still better, but it runs well, even with just one. To get rid of these, right, you see these. You gotta click these open. So if you ever repair a computer, do not just try to, do not try to yank out the RAM without like clicking these, because you might break something. But yeah, that's basically the RAM. That's interesting. 16 gigabyte to 2x8. So this is 16 gigabytes on its own, it seems. The 2x8 tells me this might come from a dual kit, so maybe they bought a dual kit, then split them up in ones for cost cutting. That's interesting. So this probably runs on 8, not 16, because it's cost cutting. But these are also not double ways. You can't just put it this way then this way. It's really easy to tell. These have a black marker. Actually, I'll put it down. Let me be gentle. Put it down like right here on the plastic. But you want to be careful, right? I don't have carpet. I have a hardwood floor. But if you have carpet, you want to be careful to not get static energy, static electricity. Though it's not that dangerous. If you touch a part, that's really dangerous on the CPU, which is why I handle these parts on the edges. Because if you have static electricity somehow, and you touch an important part of the computer, you can generate energy enough to, work your computer, make it not work. Because, you just overpowered it with your own power. It's not usually a worry. Some people who are really scared about that, they'll have like a wristband. They'll connect it to the power supply and then turn it on so that static energy can always dissipate. Those cost extra money though, so if you don't want to do that, you don't have to. But yeah, okay, let's get this in focus. All right, you can see that perfectly. The divider. That basically will tell you, right? Before you put it down, as long as you do it slowly, you'll realize that, oh, this is the wrong way. Okay, it's the other way. This is how they want it. Or take a picture if you want to. That works too. So all you gotta do is put it back in. Just align it. You'll know. and then just push it in. It does take a surprising amount of force. Some people are surprised by the amount of force you need to put on the on the RAM, but don't be scared to break it. If you've aligned it correctly, and as long as you're not pressing it unevenly, it will click. See that click? Now it's in. It's not loose. So let's go over some of the more interesting parts. This right here, I believe, is actually the LAN. No, that's the serial port. I'll be honest, I don't actually entirely know what serial ports do. Those are very business oriented. Most home computers don't really use serial ports. I believe they're used for networking. Next, this is 2 PCIe lanes. See those black bars? 2 PCIe lanes. Basically, these are PCIe lanes. They're like a type of way to send data to the computer. This big one would allow you to put a graphics. The big blue one would allow you to put, has more lanes, which would allow you to put big cards like GPUs or like SSDs are extremely fast with cooling on it. Graphics cards, in terms of what they do, graphics cards are a abbreviation of the CPU. They come after it, right? So CPUs are able to do graphics processing, but they're not very good at it because CPUs are very oriented in the way that they have, right, 8 cores, 16 threads is the most common. The i5s, I believe, are that way too, if not 4 8s. Basically, they have a few threads, and they are extremely fast, right? At 2.8 gigahertz, they are extremely fast at those few threads. GPUs have thousands of cores, many thousands, tens of thousands of cores with like the new RTXs, or the AMD Radeons, or the Intel Arcs. But because they have so many cores, they're not very fast cores. They are very they run in the millihertz. Together they run in gigahertz, but they run in millihertz. But because there's so many cores, you can have a million processes running. It's like the CPU is like a giant backpack, big hands. There's not a lot of them, but it can hold a lot of things and do it really quickly. GPUs are very tiny. They're like the fingers. Many tiny fingers. They cannot hold very much, but together they do a lot. You can handle many different tasks at the same time. So for graphics processing, because it's a lot of small math, it's not very big math. A lot of small math to make the graphics on a computer. So GPUs allow for that. They're more efficient at that, which is how we get advanced graphics. Yeah, if you wanted to, you could also put like a sound card, or even right, if you want to use a different sound, or you can even put like a network card, a NIC, right? Intel thing. Actually, I think I could probably show you. Yeah, you see that? This has a lane. This has a LAN. If you're using an Ethernet port, you could connect. Actually, a bunch right here. A bunch of Ethernet ports. Let me just connect that. So you see that, right? Bunch of Ethernet ports basically allow you to connect, which allows for a hardwired internet. Versus wireless, it just has a little bit more delay. There's not a huge difference. Most people use wireless. It works well. It's not as clunky. So you can put a card in here to make it wireless. I'm pretty sure this probably already is wireless anyways. You probably wouldn't need that. But if you wanted to, you could put another network card in. So not to get too advanced, but basically routers, they have 2 of them. Because one can be a LAN to connect to the internet, and the other one can be a WAN, or like wide access. Which basically allows the computer itself to be the router. Routers are just computers, except they can be routers themselves. Easy as that. In terms of right here, see that right there. It's back there so you can see it probably too. Basically, most computers have them. I'm pretty sure these ones are actually removable and you can put them back. So basically, all you gotta do, snap that open. And then if you want to, this has a cover on it too. You can remove the cover too. Oh, I'm not gonna play with these. I don't think these are removable. I think you can put them back, but basically you can pull this out because to get the ports through, you'd be able to put wires in, but you would need this to be open. So if they stick out, it would need to be able to stick out. They are closed by default because, well, if they don't need to be open, why have it open, right? You're allowing for more extra open spaces. But yeah, just put that back, put that through, you're good. Inside this, you can probably read it right here. Let me try to focus it. So you gotta focus. Focus. Actually, let me see. Yeah, it's focused. I didn't even realize you could see it through there. Through my phone. I thought it would turn off. But basically, that is the power supply. I can't actually see what the rating is. Instead of for our purpose. Okay, 200 watts. Max output 200 watts. It's actually really efficient. Most power supplies run at 500 or 600. Because computers do use a lot of power, so you put a graphics card in there. So this probably wouldn't actually be able to fit a very high-powered graphics card because it would probably just blow up the power supply. Because yes, they have a limit. You can't just buy any one. You have to make sure it can output the rating. So basically, you can't. So basically, these power supplies, while you can plug it in direct, you can plug it into the wall. Because these have many cables inside them. In fact, I'm not sure if I can actually open this. I probably could actually. I think this would. That would be fascinating. Let me see if I can. All right, there's a screwdriver right there. These are tiny. No, there's screws down there. You need a tiny screwdriver. I think you would need something like. You would. Yeah, this is gonna be complicated. I am doing this on the fly, but just like a repair shop, you'd be doing the same. Let me get rid of the RAM just so I don't damage it. Yeah, you would need some crazy screwdriver. In fact, you would have to probably disassemble this part of the case. Yeah, you'd have to disassemble this part. I think you have to disassemble this part before you get to disassembling the power supply. Okay. Well, that opens that part. Oh, this is the actual AIO shield. That's the cover. This you learn. This is the cover. This is the actual AIO shield. Yeah. Okay. So you can see right here what it looks like when it's naked. Wait, you can see the ports themselves, just like an actual motherboard. They look nice once you take it off. You can see it. Okay. Gotta take this part off. I think requires that you. Oh, these use a different kind of screw. I don't think I know what that kind of screw is. You always learn something. Always learn something. This is great. So, okay, there's screws right there. There are screws right there. You can see right there. This is the thing itself to plug in the power supply. I'm gonna put the AIO shield back on just so I don't bump the motherboard with it, because I think that is one of the points of it. It's to prevent the motherboard from being bumped into. Prevents damage. So if you flip the computer on its side, you won't damage its ports or the motherboard itself. Like I'm about to do. All you gotta do is put that back. Yeah, okay, come on. Make sure I put it on properly, just so I don't have issues. There you go. It's the AIO shield back on. There's a little bit of wiggling. I think that just comes from the fact that, yeah. Alright, that's fine. Alright. Now we can flip it on its side. Get rid of those screws. Yeah, in editing, I'm definitely gonna cut out some of these parts where it's just slow. Because I think the recording is getting to 40 minutes. Whoa. I don't think anybody wants to sit through a 40-minute video. All right. So I think with that you can now, or seeing me try to figure this computer out. I think that now, yep, makes it a little bit more loose. I'm sure somebody get rid of this. I think this is really like. I think Dell wants you, if you were to ever change the power supply, to just give it to them. It's just like, hey, just hand us a computer, we'll fix it for you. Because they have made this crazy. Like, it is never this hard to access the power supply. Okay, there you go. You can slide it out. There you go. Okay, after you unscrew it, you can slide it out. Figured it out. Figured it out. Right, and then there's cables at the bottom of there. Those are zip tied. I'm not gonna mess with the zip ties. I think this is as most as I can pull it out before like really getting rid of zip ties. So all you gotta do right now, just slide it back. Push it back down. Oh, this is making me nervous. What in the world? Usually not this nervous with computers, but okay, there you go. It's the thing in the back I have to pull back. Okay. There you go. So I think you can see right there is a zip tie. Let me see if I can get this focused on the camera. Yep, see that zip ties. Right, I'm not gonna try to break those because I have to put them back, and that's gonna be it's gonna be a mess. I don't have those white blue ties, cable ties. I'm not sure how Dell runs, but I know some companies, if you try to repair their stuff, they'll be funny with you, being like, "Oh, but you tampered with the computer, so therefore we cannot repair it," which is fair, but also there's a wide discussion on whether you should be allowed to repair your own stuff, or if companies should have a monopoly. All right. Well, at this point, I think we just explored most parts of the computer. Right. See that right there, that cable that runs through. Runs right here. This goes to CPU power. Right, yep. CPU ATX. Oh, this is ATX motherboard. So there are different kinds of motherboards. You have ATX, MATX, micro ATX. Yeah, like basically they're just the size of the motherboard. If you go to MATX or micro or like ITX, it just means that it's smaller, more compact. So if you want a really tiny computer, you can have like small ITX motherboards. It's like a phone. They have way less features though because they're smaller, obviously. So if you want more features, you get a bigger one that would cost more. So the smaller ones do cost more though, because it is harder to cram everything in, especially if you're trying to get more features in a tiny motherboard. All right. So after that, yep, that's about it. All right, now it's just time to reassemble the computer. RAM goes first. Make sure it's lined up. Yep. As to where you place the RAM, it really doesn't matter. You can place it on this one too. It wouldn't make a difference. On motherboards with 4 RAM slots, you would have to make sure the RAM slots are like the same, in the same sides, like same, so they can run dual channel. Otherwise, they'll just run like 2 single channels and it won't be as efficient. This one only has 2, or once it's just 1, doesn't matter. There you go, 4 mothers, 4 RAM slots. It doesn't matter, or like 4 RAM systems themselves. All right, next, put this back. Get stuck out this way. Actually, let me connect these right. It's a P3. This is the P4. All right, so this is to the CD drive, the CD reader, what it is. This is ICT. It says. So I think I can put these more closer, just so you guys see them. PC4. ICT. Alright. So you can see at the bottom of the CD drive. Yep. So you can line it up. All right, this is what I was talking about. The thing that sticks out at the top. I think you might be able to see it. Yep. Basically, they make it not two-way. Yep. All right. Here you go. Just to make sure that they align, you don't want to use it too forceful. You never do anything forcefully. Make sure it's aligned. But once you're confident, then you can put in some force. Because just like the RAM, sometimes just need a lot of force. Even the CPU sometimes needs some force to get the latch down. This one's really soft. You don't need a lot of force, but some of them you got really pushed down. So you got to trust yourself. It could be a little scary. So, yeah, if you're doing this for your first time, it could definitely be a little bit daunting. I remember my first time building my own personal computer. I think I dedicated the entire day to it. It was not easy. But as you do it over time, like I'm doing, you start speeding up. You start getting used to it. I mean, it's like a car, really. If you've ever played with cars, you kind of just get used to it. Alright. So I think I just gotta... Is there any cables in the way? Alright. Let me make sure that line's right here. Right, those things at the top. Alright, let me show you that. Yep, those would need a line to these spikes at the top. I think you can. Oh, yeah, this thing. Yeah. Yep, there you go. Push down. Yeah, motherboard connected to the case. Right. Motherboard just allows the entire computer to communicate with each other. Easy enough. Also, that long rant about the thermal paste, that basically comes from just because some people don't really realize that they need it, or sometimes they forget. When you and yeah, that leads me to this. When you buy a new heatsink, make sure they usually have a plastic cover just to protect it, right? Just to make sure it's clean. Make sure to take it off before you put it into the CPU, because some people can forget that, and plastic also doesn't conduct heat very well, so you'll realize that your computer is running really hot. All right, let's get this back. Same thing here. It's like the CD drive. You gotta plug it into the right place. Points down. Or come on. All right, there you go. I think it's just loose. All right. SATA ICT cable. There are two cables. One is the data cable. I currently have forgotten which one's the data cable, but I mean, you have to have both anyways. If you don't have both connected, it won't do anything. One is the data cable. One allows the hard drive or the SSD to be able to read and write data. The other one's the power. It's what allows for the drive to have power. Otherwise, it won't do anything. So then the plug is in. Just gotta right here. Then you can just right there. Yeah, it's a lot easier to work with when you take off the shield, this thing. It's a lot easier to work with. That is something I've learned about these kind of Dell computers. Push it on this side. I think I'm gonna push it on the other side first, actually. Let's do that. Let me lock this, because I've officially put it in. Right, so you can see these tabs. These basically latch on to the computer case. Let me see if I can focus it. Yeah, these latches. You see them. So once I pull this up, you should be able to see the latches. Yep. To the edge, like this. Attach the bottom ones and the top ones, and it fits perfectly. Right. CPU. All right, we got to this part. Reapplying the thermal paste. There's still more to learn. So when you reapply the thermal paste, it depends on the kind of CPU. Most CPUs, older CPUs, are square like this. So all you got to do, right, take this off, right, because they usually have a protectant. These have these just to make sure it doesn't dry out, otherwise the thermal paste will dry out. You don't want that. So take it off. You push it at the top, that's what allows it to come out. All you need on these kind of CPUs is just push it down, and there you go. You need like a dot size. Some people say like a rice. I put in a good amount. Basically, it's enough to switch. You don't want to put a lot. You don't want to cover the entire thing with thermal paste because then it'll just squish all over the place and it'll just be messy, even if it doesn't destroy it. But that's enough. Once you squish it down, it'll cover basically the entire die. Oh, the delidding. Yeah, when I was talking about delidding, you can delid the CPU itself. I will not be doing that because when you do that, manufacturers will know, and so they will know, and they will basically revoke any kind of warranty because they'll be like, hey, you just delidded the CPU. Because they don't like when you do that. They don't like it. Because you can do direct die cooling, which can make it even more efficient, but there are risks to that. That is like high-level professional stuff you don't want to be playing with. All right, now you just put the thermal. I believe this is omnidirectional. It doesn't matter which way I put it, as long as I line it up with the 4 white holes that you will be able to see. Yeah, they're 4. See that? Yep. Slide it up. You don't gotta worry about pushing the thing down especially once you put in the fans and stuff, or you like just push this down, drill it down. Yeah, it'll squish it through. I'm not gonna take it off to show you because if I take it off, to reapply it again, and I'm not just gonna waste. But usually, if you've applied it well enough, like when you benchmark it, you'll see the temperatures are good. There you go. And make sure it's tightened. You don't gotta tighten it too much. As long as you tighten it enough, so don't like destroy your case or your motherboard trying to tighten it like a supreme amount. It's probably good the way you have it. It does take a little bit. Sure, if I want to get more specific with the motherboard, I could talk to you specific parts of what each part does, but that's out of the scope of this video. It's long enough. It's not meant to be too complicated. Now for this part, just gotta make sure it lines up with, the other screws. I'm not actually sure this goes. No, I'm pretty sure this goes first. All right. So I gotta connect this back to the fan. There you go. Actually, I should not put that in because you guys might not see it that well, but yeah, I'm not gonna assemble the whole thing again. So at the top part, you might not be able to read it too well, but I will show you that it's there. Ooh, it focused. Fan CPU. So most ports will have an indicator, especially nowadays. They're telling you where stuff goes. Like, this is the fan CPU. This is for the other fans. This is for your RGB. If you use that. If you like colors. Basically guiding you where to put your cables, right? So you're not in the dark, which is good. If you see a CPU that doesn't tell you that, sorry. I guess your CPU, I don't know what to tell you about your motherboard if it doesn't tell you anything. So just push it down. It's not very complicated. There you go. I just gotta put the cable around. Oh yeah, it wasn't this way, it was this way. Yeah, make sure not to put this the wrong way. If I put it like this, it just won't cool anything. It literally won't cool anything. It'll just be touching plastic and the computer's gonna be heating like crazy. But yeah, just put it in lines, right? You see that? Actually, let me take that off so you guys can see it. You see those wrench looking things sticking out next to the, see that right there? Yep, those align with these. Yeah, that one. This idea is screw down the fan itself. Yeah. Okay. I see. I did it wrong. All right. There we go. I missed a step. This goes first, and then this goes. Make sure it's all right. All right. There we go. I might go back on the recording to figure this out. What in the world I am not doing well on this. Did I play it the wrong way? No, it was not the wrong way. Okay. It was probably this way, huh? Yeah, it was probably, yeah, this looks right. This looks right. It's supposed to be this way, not this way. Oh yeah, that goes in well. That gets in well. All right. This is the screw. This is what we saved the screws for, so we can put it back. So now we just get a screwdriver. Yeah. Those are the power supply ones. Just gotta make sure to put those back, and not forget. Audio still recording. Let's close the video. All right. Oh man, I hate when that happens. Yep, this is not ideal. I did get a screw lost in there. That is not the first time that happens. It's not the first time that has happened. Yep. Alright. You know what? Let's try to find it. I'm gonna be proper with this. This isn't my computer. If this was my computer, yeah, I'd be more than willing to just let the screw stay in there. I would be limiting. I'd just leave it in there. I'd be like, whatever, it's a screw. But this is not mine. This is lended by the school, by a teacher. So I'm gonna go through the hard work again. All right. Got here. That you have to do it the first time. Getting that out is a lot easier the second time. Yeah, I gotta disconnect all the cables. Hopefully. Where is the screw at? Where is the screw at? Ah, there we go. I see it. All right, it's at the corner. Let's try to wiggle that out. Yeah, I'm gonna have to slowly turn this. There you go. Yeah, all right. There we go. Oh god, I hate screws so much. Alright. I'm gonna screw this in first. I'm not gonna even risk that anymore. Put this in first, and then put the other part in. So now it's well in. Yep, it's in. Let me tighten this a little bit more. Be careful with the motherboard, because you can have times where if you're getting frustrated, you can maybe bump the motherboard with your screwdriver, which is not good, but most of the times it shouldn't cause damage. Alright, yeah. I think that's as good as the fan is going to get, which is fine. It's aligned. Yep, everything looks good. This does wiggle a little bit, which does frighten me a little bit. I believe it always wiggled, though. If I go back to the beginning. Alright. But I'm not going to tighten it anymore, right? It's tightened enough. Oh, the cables not going to need any hidden cables. We'll do a segment talking about right to repair, because I do actually believe in people's abilities to repair things, but that will be after the video. Because while that's not directly related to this video specifically, I think it's important. I don't think this said F on it. So, at least on Intel CPUs, if they have an F on it, it means they've disabled or gotten rid of the graphics processing unit, which means you need a discrete one. They are cheaper because, well, there's less of the computer, so they tend to be cheaper. But because if you don't have a graphics card, the computer will basically not boot up because you can't process any graphics. Non-F means that, hey, the computer has a graphics card, you don't need a discrete one, though if you have a discrete one, it will run faster because if it has its own power, its own everything, it will be quicker. K means unlocked. That is very advanced. Basically, if it's a K, it means it's the computer. So normal computers have their boundaries, right? The software, the firmware will not let you push the computer to super fast speeds or high wattage or voltage. If it's unlocked, it will let you do that. If you destroy the computer, that's on you. But for advanced people, they may use that to like get extra performance out of it. It also allows you to lower down the parameters, which can actually be really good. Well, I don't think you need a K for that, but if you lower down the power, you may find the computer can run the same, and you'll just be conserving power, it won't generate as much heat. So good for the environment. The K limits, they're there because basically the computer manufacturer has decided that, hey, if you push it beyond the K limits, the limits that have been set by the manufacturer, the CPU will run a little bit faster, but in terms of trade, in terms of wattage, it will not be very efficient. It'll go faster, but you use a little bit faster, but you use way more power. And, well, that's not good, right? It's not very good for the environment. So I will give that as a plus for most CPU companies. They do care about the environment at least a little bit. A little bit. Oh, and on repairing. You know what? Yeah. Most desktops are actually pretty nice when it comes to repairing. If you're working on MacBooks, God bless you, because they put 3 million different types of screws on MacBooks. Not to say MacBooks are bad. They are really good. Most people use them. They're good for travel. Apple does a good job. But when it comes to repairing them, you can search it up, and it's basically impossible. It's not impossible, but it's crazy hard. The reason it's crazy hard is, actually, there's no good reason. It's just hard. They made it hard, right? So, I'll keep talking about that later. Right now, we're just going to put this on. Right, so you got everything in. Just line it up like this. And then, oh, turned it this way originally. Ooh, before I forget, let's screw that in. Screw that in. One and a two and a three. Just so the power supply isn't loose. Or power supply unit is its full name. Alright. There you go. And there you go. What you gotta do now? Now you can line it up, and which way? This way. Yeah, this way, this way. No, this way, but that way. Hate this. All right, there you go. Now the computer. Come on now. What's loose? What is going on here? What is going on? Come on now. All right, it's back. Oh, this is Windows 11. According to this, it runs on Windows 11 OS. Checkmarked. That is interesting. This might have had a lockdown mechanism. However, if you put it in enough, that's probably why this computer was so easy to open. There is a lock mechanism here that doesn't exist. I was very, very surprised to see that it was very easy to open. I was like, why does it open like that? Usually, it's a little bit of effort. All right. The point is, it's here. If I were to plug it in, it should turn on just fine. In fact, I think I have a thing that should allow me to. And there you go. I'm gonna turn on this computer just as a check to, basically let everybody know that, hey, I've put this back together. The computer still worked when it was in my hands. You do need this because of the fact that this power supply runs like this. Really long recording. Cool. So, yep. See that blue thing? Turn it on. Don't believe this actually runs on. Oh, it has a display port. Oh, yeah. So, HDMI, display port. These are two different standards. Honestly, there's not necessarily one that's better than the other. It keeps changing. Because there's actual competition. Hey, the cable market, there's a competition because if you have the best cable, it'll run the best quality and have the most features. So this runs on this. I'm gonna put in DisplayPort because this is the one I have available. So I believe it's this way. All right, there you go. All right, let's switch the display. I'm not sure if the microphone can pick it up. I'm not sure if it picked it up, but the fans are on. The fans are on. The fans are on. The fan is on. Alright. So now if I switch to DisplayPort, input source, DisplayPort. There you go. It's running. I will actually take this off just so it is in fact running. It is good in my hands. Time, okay, you won't see it, but time delay not set. Please set up. All right. Keyboard not found. Yep, I didn't put a keyboard on there. I'm gonna leave it like this. I believe this might be a brand new computer. I think that's why that is showing up. The time of day not set, which is actually interesting. They trusted me with a brand new computer. All right. You know what? Fair enough. Yeah, it's the service tag. It has the BIOS. It has everything. But this computer, point is, it worked in my hands. Alright, now I'm going to switch it back. Just need another one. Alright. Got the recording running. Still works while it was in my hands. Alright, now I will get on my spiel about right to repair. So, there is a complicated movement, basically, where today, many companies, right, now companies have gotten better on this, but you still have companies like Apple, who are notorious for making it extremely hard to repair their systems. Because they will put in many different types of screws. They start putting stuff like, hey, your part is not genuine. Hey, your battery is not genuine. So they may put special firmware on it just so it tells them like whether the part is genuine. Honestly, this genuine is not doesn't really, it's not really a thing. If it runs together, it works. Genuine doesn't really matter, right? I guess in the sense of like you don't want to buy a fake CPU, I guess, but like if it's a legitimate part, it should work together. But they purposely do stuff like, hey, it has to be genuine by making to drive up the cost of repairing. Hey, you have to buy this part from Apple, so Apple gets to mark you up because they have a monopoly on that part. Hey, or even back in the days when they made extremely hardware, the only place you could repair your Apple products was at, guess what, Apple. So they could charge you exorbitant amounts, or maybe charge you to a point where it's better for you to just buy a new phone. It's cheaper to buy a new phone. Why repair it if you just buy a new one? It's very scummy. That kind of practice should end. That's why you have right to repair movements. You have legislators who actually have put in, laws to make sure, hey, you have the right to repair all things. Hey, Apple, you should try not to just be exorbitantly hard to repair your products or even other companies. Right. To get to that's about it. There's not really too much to say about that. That is my short spiel about it. You notice here that a lot of the parts here were also removable, right? I could remove any of these parts. In laptops, not all parts are very removable. They would, what we call soldered. They're like pasted directly onto the motherboard. That has an advantage for the fact that because it's directly on the motherboard, it is quicker. It's the best technology. However, because it's directly connected to the motherboard, if you wanted to change it, you'd have to literally melt parts of it to be able to get parts out and swap it back in. Even then, it might not work. It's not standardized. You might have the best of the moment, but you're gonna have to buy a whole new one, and it's way more expensive. But yeah, basically that's it. If I have anything else, I'll add on. Otherwise, see ya.